So good evening everyone. So today we will be discussing continuation to the last class. So what we discussed in the last class, tell me once. The basic terms. We have started from very basic, like what exactly matter and its classification and units to express expressing physical quantities, all these things right now, and also unit conversions, like what are the units we'll use for volume, how can we convert them, next temperature like kelvins, Celsius, Fahrenheit, what is the relation between those things we discussed right now. To go. Rafia na Paint. Oh. Okay, fine. So now, so we'll discuss the continuation to that. Like Dalton's atomic theory we have discussed, and law of chemical combinations, like law of conservation of mass, these things we discussed now. Yeah. So and I also told that law of conservation of mass is not applicable in case of non-stoichiometric reactions and also isotopic effect. When there is isotopes we cannot use it, okay, that will not be applicable here, okay. So now here we will be discussing what exactly an atom. See, an atom is the smallest unit of matter that retains the chemical properties of an element, okay. So now if I say carbon element, the carbon element properties can be completely studied by analyzing a carbon atom, okay. Now it consists of nucleus, atom means atom consists of nucleus which contains protons and neutrons, okay. And in the nucleus, for example this is the atom, so I am saying here nucleus. So in these we have protons, positive sign I am indicating, and along with that neutrons we have, okay, there is no charge on neutron, okay, and electrons orbiting around the nucleus. If this is a nucleus, so in these we have electrons in which orbital, like electrons were revolving in these orbitals, like in these orbits, okay, these are called orbits, they are saying orbiting. So in these we have what, in these orbits we have electrons, okay. So now atoms combine to form molecules and they are the building blocks of matter, okay. So atoms combine to form molecules, okay. So any matter is made up of what, atoms, so that atoms may combine to form molecules. So all those together we are considering it as matter, okay, yes. So something like this you can see the low inner part, see blue and red color indicates nucleus together, okay, and these electrons are revolving around this nucleus. Are you able to see this in the image here, okay, yeah. Next, so atom combine to form molecules, okay. So for example hydrogen atom, carbon atom, so oxygen atoms, for example hydrogen and oxygen is combining in some ratio, that specific ratio we discussed, to form water molecule. So here what is that specific ratio, I told in the mass ratios, like 2:16 or 2:16 or 1:8. Yesterday we discussed this, okay. Next, when carbon and hydrogen are combining we can expect to get methane, okay. So what is the ratio of their masses, I told you 12:4. So this will be 3:1, okay. So 3 parts of carbon, 1 part of hydrogen, like that, okay, by mass, okay. This is what you need to understand, okay. Next, what is a molecule? Molecule is a group of atoms, like group of 2 or more atoms, like at least 2 atoms should be there, 2 or more atoms combine to form a molecule, okay. So now these atoms will chemically bind together when they are forming a molecule. Okay, for example, just now I told you water molecule, it is a combination of two hydrogen atoms and one oxygen atoms. If I say oxygen molecule, it is a combination of two hydrogen oxygen atoms. Now if I say nitrogen molecule, it is a combination of two nitrogen atoms. Okay, so atoms combine to form a molecule. Okay, so now atoms have atomic weight, molecules have molecular weight. Okay, so now we'll come back to this, wait for some time. So look at here the basic thing. So if an atom of an element has twice the mass of, okay, so now look at here. For example, I am showing you CaCO3. So just use here the basic thing you can understand here is calcium carbonate I have given you. So for this, if I ask you to find what is the atomic weight or this molecular weight, this is a molecule, no, completely. So molecular weight I am asking, molecular weight I am asking. How you are doing this? See, for calcium, what is its atomic number? 20. Okay, atomic number of calcium is 20. So it has 20 protons and 20 neutrons. Okay, neutrons plus protons is its a mass number. Okay, mass number I am indicating with A. Okay, so therefore for calcium I should take 20 plus 20. So 40 here plus. Carbons are, one carbon atom is there. So for atomic number 6 means 12 plus 3 oxygens, 3 into 16. Okay, so it will become 40 plus 12 plus 48. So it will be how much? 100 atomic mass units. U I am writing small. Okay, so this is what the atomic mass like molecular weight of this CaCO3, calcium carbonate. Now just tell me for this one, for glucose C6H12O6. Yes, tell me for this. Tell me for glucose. Once again, 6 into 12 plus 12 into each hydrogen is 1. So 6 into 16. So how much here? So this will be 72 plus 12 plus 96. So if you solve this, see 4 plus 6, 10, 0, 1. So it will be 10, 11, 7. So 180 right now. So what is the atomic mass unit for this? I mean molecular units, molecular weight is 180, you should say. Okay, hope this is clear. Yeah. So try to find for these things. H2SO4, HNO3. Okay, just try these questions. These two are enough here. Okay. Now look at here. You can do that. So average atomic mass I am saying. So what is this average atomic mass? See, when we are extracting something from earth crust, or for example you wanted to extract some element, okay, let us say chlorine element we are extracting, okay. So when we are extracting it, whatever the possible isotopes are there for that particular element will come in that extraction. So it means chlorine has two isotopes. What is mean by isotope here? Yesterday we discussed na C12, C13, C14 like that. They differ in mass numbers right now. So for chlorine I told Cl35 possible, Cl37 possible. Okay, these are the two possible isotopes. Okay. So now when we extract chlorine, we are going to get the both things. Now when I say average atomic mass, it is a average weight of both isotopes. Okay. So what is the average atomic mass of chlorine? That will be 35.5. Okay. So how you are going to get this value? See, in the existence, I am saying when we extract this, we are going to get 75% of Cl35 and 25% of Cl37. Now we are asking about average atomic mass. So how you are going to take here 75 is there now. So 75% into 35 plus 25 into 37 divided by percent, we are saying now, so overall will be 100. So if you simplify this, you are going to get something like 35.5. So this will be the average atomic mass of chlorine. For Cl35 it will be 35, 37 it will be like Cl37, 37 is the atomic mass. Okay, but for average means consider both of them and percentage abundances. Now I just want to make you one generalized formula here. So what I can make is, I can make here average atomic mass is equals to percentage summation of percentage abundance into its atomic weight by 100. Percentage abundance here 75 into its atomic weight. Summation means plus 25 into again 37. If any other elements are also there, again plus, like that. Any isotopes are there, you just add them like that. Is that clear? Okay. This is how you need to calculate average atomic mass. Okay. Clear with this? Yeah. Next. Yeah. Next thing is formula mass unit. See, whatever you did for molecular mass unit, I mean molecular weight, same thing here also. But we use this term formula mass unit when it is an ionic compound. Ionic compound like NaCl is there. It is an ionic compound like Na plus Cl minus we have now. So for this you should say the term is formula mass unit. So this is the formula of NaCl ionic compound. So for sodium it will be 23. Okay. For chlorine it is how much we got average? 35.5. So how much it is? See 0.5 as it is, 5 plus 3 8, 58.5 units like this. Okay, is this clear? Yeah. Next. So now just look at here, molecular mass of ethyl alcohol will be, tell me mass, molecular mass of ethyl alcohol, just answer that question. Forty-six. Okay. So how you are getting? 2 into 12, very simple now, plus 6 hydrogens are there, 6 into 1 plus 16. So 24 plus 6, 30 plus 16, 46. So your first option will be your answer. Okay, this is molecular mass. Okay, they will ask something like molar mass. I will tell you what exactly molar mass. This is for 1 mole of substance. Okay, so when they say molecular mass, here I am using unit as U, small u, atomic mass units, or sometimes it is also said as AMU, atomic mass units. Okay, next. Okay, glucose already we did 180. Which option is this? First option. Just now I told you the difference. This will be the answer when it is molar mass. This is molecular mass, means mass of one molecule. This is mass of 1 mole of molecules. Okay, yeah. So formula mass of K2CO3 is how much? Take this as a question. Don't, like, you can practice it later. Just write it. K2CO3. You have an option? Yes. Next. So, symbol of an element. How can you indicate an element? See, there is some element. Let us indicate that element like this. Okay. Now, mass of that element will be indicated here. I am indicating A is the mass of that element. And atomic number of that element is indicated here. Z is the atomic number. And if there is any charge on that, you should indicate at this position. So this position is for indicating charge. And here one more position I am making here. So this position is for atomicity. So what is atomicity here? Number of atoms. For example, I am writing N2. What is the atomicity of nitrogen here? 2. So atomicity will be 2 like this. Now I am writing O2 minus 2. Now tell me, what is the atomicity? 2. What is the charge? Minus 2. Is that clear? See, what is the X here in this case? Oxygen. Element is oxygen here. Is that clear? This is a standard way of representing like element. Okay, in its atomic form, neutral form, I mean ionic form, everywhere. Okay, yeah. So this position is for mass number. A indicates mass number, Z indicates atomic. So for example, here I should use, for oxygen I should use, what is the number here? 6. Atomic number for oxygen is how much? 8. Okay, so use that here. Okay, next. See, here I am using C612. So 12 indicates mass number, 6 indicates so number of protons, 6 atomic number now. So 6 atomic number given by number of protons in that atom. Okay, next, number of electrons are also 6. Okay, neutrons are how many? So how you got? Like 12 is a number, indicates what? A is equals to mass number now, that comes from protons plus neutrons. So we know 6 protons are there, mass number is 12 we have. So I just want number of neutrons, this is small n. So small n will be 12 minus 6. So 6, that's why 6 it is. Okay, see S minus 2 I have. What is the mass number it has? So 32. Now atomic number? So number of protons are 16, so atomic number is 16. Now number of electrons? 18. Why 18? Proton number, like for an atom, an element in its atomic state, have equal number of protons, equal number of equal number of protons, equal number of electrons, all the times. But when it is in ionic form, for example here it is in -2, it means electrons are added or removed?
Added.
How many added?
2.
2. So it means 16 electrons already will be there, this plus 2 electrons are added. So total how many? 18. That's why number of electrons I have mentioned here.
18.
If I write the same element like 16 here, something like plus 2, what does it mean? 2 electrons removed. So how many electrons are there now? 16, you remove from 16 2 electrons. So how many electrons? 14. So like that you should answer. Okay. Now one more thing here. How many neutrons are there? 32 mass number means 32, like use this 32 minus 16, you are going to get remaining 16. So number of neutrons are 16. Okay. So here also Fe plus 2, tell me for this Fe plus 2. Mm-hmm.
24 electrons.
Okay.
26 protons. 26 protons. 24 electrons. So 30 neutrons.
Yeah, tell me.
26 protons.
26 protons, 26 electrons are
24.
24. Why? Just plus 2 is there, removed. If it is Fe plus 3,
Fe plus 3 electrons are removed.
so
23.
3. Okay. Electrons are 23. Protons? Protons will be same, like it won't change, only electrons are removed. Okay. Next 56 minus 26
30.
gives what?
Gives us neutron.
Neutrons. So 30 neutrons here. Okay. Just use number of neutrons equals A minus Z. A is mass number, Z is atomic number, like protons, number of protons. So gives what? Neutrons number of neutrons. Okay. Next, now we have very important topic like mole concept. What exactly mole concept is? What exactly mole concept is? So tell me here, when we go to any market, we generally ask like dozen apples or dozen eggs, something like that. Dozen means 12. This will be the usual daily language we will use. Okay. But in terms of chemistry, we will be discussing with very small particles like atom. We can't even see it right now. Electrons, very small particles now these are. So even if we take small quantity, it has large number of particles. Yes or no? Even if I take some 1 or 2 grams, it will be have large number of particles in that right now. So in order to express this, we have a term called mole. Similar to dozen, we have a term called mole. So this mole indicates, this mole has, it is practically observed, it contains 6.022 into 10 power 23 particles. If I say 1 mole carbon if I say, it contains Avogadro number, this number is called Avogadro number, into 10 power 23 carbon atoms are there. If I say this 1 mole carbon, this many number of carbon atoms are there. Okay. Now anything, see how, just read this statement once. 1 mole, it is defined as the amount of substance containing as many atoms, molecules, ions, electrons or any other elementary entities as there are in the exactly 12 grams of carbon, C12 carbon. So it is observed that when C12 carbon is taken, how much C12 carbon is taken of 12 grams. So C12 carbon of 12 grams is taken. Now in this they have observed that contains Avogadro number of particles. Avogadro number is nothing but this number. Okay, this is a practical observation. Okay, so that's why. Now 1 mole if I say, so it corresponds to how many particles? 6.022 into 10 power 3 particles. Now if I say 1 mole carbon, if I say 12 grams of carbon, 12 grams, if I see, instead of saying, see what I told you here, 12 grams of carbon contains this many number of particles. This many number is nothing but 1 mole. So 12 grams corresponds to, 12 grams of carbon is corresponds to 1 mole carbon, which is also equals to Avogadro number of carbon atoms. Okay, now I am giving you 6 grams of carbon, half mole it is. So half of this Avogadro number, like half of this 6.022 into 10 power 23. So what you are going to get? 3.011 into 10 power 23 will be your answer. Okay, so now if only 3 grams is given, 3 grams of carbon is given, that is 1/4 moles of carbon it will. I will tell you how it is. So just look at here, a pair of shoes, it means 12 shoes we are saying. A dozen of eggs, 12 eggs. Similarly, a grass of pencil means 144 pens. If I say 1 mole of hydrogen atoms means Avogadro number of hydrogen atoms are there. Okay, is that clear? Okay, now hydrogen atoms, atomic weight like gram molecular weight or molar mass. The hydrogen atom, if I take 1 mole of hydrogen atoms, its molar mass is observed to be 1 gram. Okay, now 1 gram of hydrogen atom, what is the number of hydrogen atoms present in 1 gram of hydrogen atom? Avogadro number. Half gram means half of that Avogadro number, half mole I can say. Okay, now. Okay, so now what I am saying is molar mass. What is this molar mass? Mass of 1 mole entities in grams is considered as molar mass. So mass of 1 mole of entities, 1 mole contains this many entities right now. So if we take this many entities and if we weigh their weights, we are going to get its molar mass. Okay, so is that clear? 1 mole of mass of 1 mole of any substance is called as its molar mass. Okay, so molar mass units are gram per mole. Okay, see, it is also called as gram atomic mass for atoms. For molecules, gram molecular mass, molecules. Okay, so now look here, 1 mole weight of 1 mole of substance is called molar mass. Now I am saying, just now you have seen 12 grams of C12 is taken, 12 grams of C12 carbon is taken. So this 12 grams is nothing but 1 mole of carbon, 1 mole of carbon. Now mass of 1 mole of carbon is how much? 12 grams. This is also called as molar mass of what? Molar mass of carbon you can say. Okay, now here I just want to give you one formula here. Mole is indicated with the symbol N. Okay, so now 12 grams means 1 mole, 6 grams means so you are going to get that half mole by using this formula. See, weight, given weight by its atomic gram or molar mass. So given weight is how much I am giving you? 6 grams. So 6 divided by 6 grams I given by 12 gram per mole is the molar mass of this carbon. Okay, so number of moles will be how much? Gram remove, so 1/2 mole. Okay, so next Now what is the general formula you need to remember here? Number of moles is calculated using given weight by molar mass of that substance. Okay, yeah. Next, now I am saying you, let us say O2 is given, 16 grams of O2 is given. How many moles it will be? How many moles it will be? Number of moles formula, given weight by molar mass. So given weight is 16 grams. What is the molar mass of O2? See, for atomic number of oxygen atom is 8. So 16 for oxygen atom. It is a
2.
so 16 into 2, 32. So here 32 gram per mole. So 1 by 2 mole, like this. Okay. After this, I just wanted to give you number of moles in number of moles if weight is given as, if weight of methane is equals to some 16, let us say 32 grams. Dash number of moles if weight of methane is given as moles of methane, if 32 grams of methane is given. So tell me. So tell me, number of moles I am asking by giving its weight. How do you do? What is the formula? Given weight is given. So divide it with the so what it is will be? So given weight is
22.
Molar mass of methane is, don't think too much like methane.
4.
So 12 plus 4, 16. So take here 16. This will be
2 by
2. So number of moles will be 2. Now in these 32 grams, tell me number of moles of hydrogen. Number of moles of hydrogen. Number of moles of hydrogen, tell me. So here given, see, just look at here, methane is there, no? So if I say 1 molecule of methane, how many hydrogen atoms are there? 4 hydrogen atoms are there. If I say 1 mole of methane, how many moles of hydrogens will be there? 4 moles of hydrogen will be there, right now. So but in the given question, 32 grams corresponds to how many moles? 2. If it is 2 mole, then this will also becomes how much? If it is 1, 4. If it is 2, 8 mole of hydrogens will be there. Okay? Yeah. Next. So if I give 2 moles of CO2 is given, then its weight is how much weight it will be? I given moles here, I am asking its weight in grams. What is the simple formula?
Weight by molecular mass.
Okay, so how you are doing? So number of moles equals to weight by molar mass of that substance. Number of moles is 2, molar mass of CO2 is 44, so weight will be like this. Okay, so 88 grams. Okay, this will be the weight. Okay, next. Okay, so I am giving you 0.5 mole of glucose. 0.5 mole of glucose. Then its weight in grams. Then its weight in grams. So its weight in grams. Tell me. Huh? So number of moles is given again, weight by molar mass. So number of moles is how many? 0.5. Weight I want 180 here. So you want to find this weight. So weight will be 0.5 is nothing but 1 by 2 into 180. This will be 90. So how much it is? 90. How many grams? 90 grams will be your answer. Okay, is that clear? Okay, next we'll move forward. I hope you got how to calculate weight from number of moles and number of moles from weight. Basic formula, it is very important again. Okay, now some conversions. To convert mass in grams to moles, what is the formula used? Mass to grams, mass to moles, just weight by given weight by molar mass. Okay, yeah. So number of moles, n equals to given mass by molar mass. Okay, so now sometimes what they will give is number of particles they will give, and they will ask number of moles it is. For example, 1 mole of a substance contains how many particles? 22. Avogadro number I told now. 1 mole contains Avogadro number, that 6.022 into 10 power 23. Yeah. Just hold on for few minutes. I will tell you that. Live session. Yeah. Next discussion is on volume. Just hold for few minutes. Okay. So here 1 mole means Avogadro number. So that will be 6.02 into 10 power 23. Okay. So now I am asking, like, by giving some number of particles, how you are going to find this number of moles. Okay. So for example, I am giving you half mole I am giving. So what you should do here, see, if it is half means this is also becomes half like this, yes or no? So you can use one method called unitary method here. So you need to find number of particles here, that x you need to find. So multiply this number with this and this number with this. So x into 1 mole equals to half mole into Avogadro number. Right now, so this mole here cancel, so you are going to get your answer as half Avogadro number. So what is the formula you got? Number of particles is equals to, you got a formula, number of particles or entities equals to what you got here, given, like, see what you got, number of particles equals to, so you are multiplying these things now. See, number of moles, see here what you did. So 1 mole means you have multiplied with this, and half number of moles into Avogadro. So what I can say, number of moles into number of moles. Here how many moles they given, find it into Avogadro number. For example, I am giving you 2 moles, it means 2 into Avogadro number. If I give 5 moles, Avogadro number, like that. Okay, so now I am giving you some 16 grams of methane, 16 grams of methane. Okay, so tell me number of particles here, particles, number of methane particles, so tell me number of methane particles. 16 grams of methane I am giving. Grams. So what you need to do first, convert this into number of moles, multiply with the Avogadro number. You will get the answer. Just do that. So number of moles is how many? 16 grams by molar mass of methane is 16. Okay, that is also 16. Okay, so you got 1 mole. So 1 mole means I am asking number of particles, number of methane particles. What you need to do? Into how many moles you got? Multiply that with Avogadro number. That 6.022. That number is there now. Multiply with that. Okay, that will be your answer. Okay, now one more method you have. So that is, see, if they ask number of moles by giving number of particles, just use this formula. Number of moles is equals to given number of particles, given number of particles by Avogadro number. Okay, so now one last method is there. See, volume, like, see, if you consider any gas here, so 1 mole of any gas, 1 mole of gas occupies 22.4 liters of volume. This is at a STP condition. At what condition? STP means what? Standard temperature and pressure. Temperature should be 0 degrees Celsius or 273 Kelvin you should say, and pressure should be 1 atm, atmospheric pressure. Okay, that will be the things. So these are standardized. So at this standard temperature pressure, at this constant temperature pressure, the volume occupied will be how much? 22.4 liter by 1 mole of that gas. Okay, so now they will ask by giving some 5.6 liter of gas is given at STP, and they will ask how much volume it will be, how many moles it will be. How do you do? So number of moles, use this formula, number of moles will be equals to, just I am getting this from unitary method, like I told now, multiply with this, multiply with this. So number of moles here I want, this N will be equals to, what you will get? N into this number into this. So it will be 5.6 by 22.4 liter. Okay, into moles you will get. So if you remove these two things, you are going to get 1 by 4. So it will be 1 by 4 mole will be your answer. So what is the formula? Number of moles will be equals to given volume at STP by 22.4. Okay, that should be here, it should be liter, then this should be also in liter. If it is in ml, convert this also into ml. Okay, so divide that, you are going to get number of moles at STP. Okay, now I am saying you 11.2 liter O2, write the question, one last question it is 11.2 liter O2 gas at STP has x grams of weight. Tell me that value of x. See what I told you, first given volume at STP, convert into number of moles at STP. How do you convert? Given volume, how much I given?
11.2.
Divide it with 22.4, so that you will get a number of moles. After getting that number of moles you got, what is the relation between number of moles and weight? Number of moles equals to weight by molar mass. Do that, you are going to get the answer. Okay, so done. Yeah, so with this I can wind up the class. Okay, just solve this, I just want answer from your side. Okay, so then next you have physics class now in continuation to this. Okay, so thank you for watching. Those who are in online session, so if you are new to this channel, just subscribe the channel and stay updated with us.